Hello, this is the first video of Extreme Electronics series. I'm going to make a USB charging station that can charge 100 devices at the same time. It charges via USB-C like most modern chargers. I chose it because USB-A feels outdated. Let's get started. First, circuit boards. I designed and manufactured these circuit boards that can charge via USB-C. Have a closer look. There are very fine elements. On the board, there are silver parts. These are called pads. I'm going to mount components on these pads. But before that, I need to apply solder on the pads. This is a stencil. When you look closely, you can see holes in it. I will apply solder into these holes on the stencil. As for the type of solder I'm going to use, it's not the bar-shaped solder like the ones we used in school classes. I'm using solder paste. Now, I'm going to secure the circuit board on which I'll apply the solder. If you don't secure the board firmly, it will be very difficult to apply solder. The solder won't be applied on the right places. Now that the board is secured, I'll place the stencil on top of it. You need to align the holes in the stencil with the pads on the board. If they are not precisely aligned, the solder paste won't be applied right. In most cases, you don't do this kind of work by yourself. The machines do all the work, such as applying solder and placing components. Those things are usually done by the machines. The holes and pads are perfectly aligned. You can't see the red part of the board. Now let's start applying the solder paste. To apply the paste, you need a card. You can use your credit card or something. The card works like a spatula. Push and slide the card to spread the solder paste on the stencil. Rather than spreading, it's more accurate to say pushing the paste into the holes. It requires a lot of force to apply the paste. Wonder if the paste is poorly made. My hands are tired already. As you can see, I'm having quite a bit of trouble applying it. It takes about a minute to apply solder paste to a single circuit board. This is such a large circuit board. I've never manually applied solder paste on a circuit board of this size. I'm really struggling. Usually a machine applies the solder paste on the board. When done by a machine, it usually takes less than a second to finish. After applying solder paste, I'll have to place the components on the board one by one manually. Typically, such tasks are not performed manually. If it were a smaller prototype board, sometimes people do it, but it's quite a hassle. I've finished applying the solder paste. It's applied quite nicely, isn't it? I finished the first board, but actually there are 9 more left. I will apply solder paste on all of these as well. I have finished applying on all the boards. I will now start placing components on the circuit boards. It's such an exhausting job. Placing components on the circuit boards was an incredibly hard task. When I ordered the circuit boards, I could have had all the components mounted and soldered to them, but I didn't choose that option. To be honest, I terribly regret it. However, placing components by hand makes a more interesting video. For the charging ports, I'll use USB-C. I chose USB-C because USB feels a bit outdated. If I make a charger, it has to be USB-C. I'll take out all the components. Since the charger can charge 100 devices, there are 100 sets of components. These components I'm taking out are chip resistors. Their size is 1.6 millimeters by 0.8 millimeters. They are extremely small. I will need to carefully place the components manually one by one. These are IC chips for USB charging. They are very important components for charging via USB-C. Without these, the charger will not function. This is where it gets really hard. I'll place each component using tweezers one by one. This task requires a high level of concentration. Please enjoy the process of placing the components for about 30 seconds. All the components have been placed on the board. There are 90 components. It's not finished just yet. I need to melt the solder on the board. In order to melt the solder, I will grill the circuit board. I said grill, but I won't set fire on the board. I'll use an electric griddle. I'm actually going to grill the board. The griddle evenly heats the circuit board and melts the solder. Can you see? The solder is gradually melting from the upper right. It's done. This is the finished look. I think it turned out quite nicely. There is a green component at the top right of the circuit board. This is a terminal for supplying power to the charging board. It's the only component I soldered myself. Then I placed the electrolytic capacitors and the USB components on the rest of the boards. That was a pure nightmare. There are still so many components to put on the boards. I had to carefully place the components by hand on the board one by one. To put it lightly, it was absolute hell. Usually all the work of placing the components would be done by machines. However, this time I did it by myself. I made 10 circuit boards. There are 10 USB chargers mounted on each board. Actually, you can charge devices only with this board. If you connect a 5-volt power supply to this board and plug in a USB cable, you can charge devices. Let's move on to the next step. I'm going to stack these 10 circuit boards on top of each other. Of course, you can finish by just stacking 10 boards and connecting a power supply, but it wouldn't look nice. So I prepared this kit to make an aluminum open airframe case to cover the circuit boards. Now I'm going to assemble the aluminum case. These aluminum rails are very sharp at the end. You might hurt your fingers, so it's better to wear gloves. I made a simple assembling instruction myself. I'm going to assemble the case following this instruction. First, I'll assemble the top part where the handles will be attached. There are 2 handles. I will attach them to the top part so that they can be held like this. This part in the instruction. Firstly, I will place the parts that support the corners of this aluminum frame. I'll attach the parts by tightening the screws. Arrange the parts like this at the corners of the aluminum frame. Then tighten the screws and nuts onto the triangular parts. When it's done, put them in the corner like this. It goes here. Repeat this process for the rest of the corners. The handles will go there. I'll attach the handles before attaching other parts. I attach the screws to the handles. I'll use them to attach the handles to the aluminum frame. I put the nuts in the aluminum frame beforehand. I'll do the same on the opposite side. For now, I'll fix them temporarily. Aluminum frames are the best when making a simple prototype like this one. They're easy to work with. I should be careful not to secure the corner parts before attaching the handles. I'll attach the handles first and then secure the corner parts. Once all the screws of corner parts are loosely tightened, tighten them firmly. It's done. It feels like a solid frame. Just like the top part, the bottom part of the case has been completed in the same way. Stand the rails vertically at all the corners and secure them with screws. On top of the rails, place the top part with handles. Then it's complete. Just like what I did when I assembled the top part earlier, I'll use these triangular parts to secure the corners. Now, only a few easy steps are left. I might have made a mistake. I'm supposed to put nuts in the rails, but I can't put them into the rails on this side. I need to disassemble them. The top part is the same. Since the nuts won't fit, I'll have to disassemble it. But it wasn't such a big mistake after all. If you shift the rail, the nut goes in easily. You really have to be careful when you assemble something. It's difficult to get this in here. There's a possibility that the assembly instructions were incorrect.
お、入った。
The frame is finally complete. It looks quite nice, doesn't it? Even if I swing it around, it doesn't seem like it will break. Pretty solid. I've assembled a box to put the chargers in. So what are we going to do next? I'll place some suitable metal plate at the bottom. I'll skip the explanation as it became lengthy. What I'm doing here is to put the charging boards and the switching power supply inside the frame. Now I'll stack the circuit boards. I just stacked half of the circuit boards. It's already looking great. I feel like it's pretty cool. I chose red color for the circuit boards. I think part of the reason why they look cool is because the color is red. Circuit boards are usually green, but I chose red ones for this special occasion. I stacked 10 circuit boards. They are quite heavy and feel solid. Seeing them stacked together, it really looks awesome. I will place 2 switching power supplies here. And then I will place the USB charging board that I just assembled. Now, the exterior is finished. You use it by inserting the cable like this. Of course, you can charge from any port. I didn't realize this before assembling, but after assembling, I noticed a significant flaw. 10 circuit boards are stacked together for this charging station. Can you see the top board? It's right here. If you try to plug in the charging cable at the top board, you can't insert it because the aluminum frame interferes. It's about 90% complete. There are switching power supplies at the back and there are charging boards. You need to connect them with wires. A maximum of 15 amps will flow per board. So you need to use wires that can withstand the current. These are the wires I got. I'm going to connect them. It's an easy work. The wiring connecting the power supply and the circuit board looks like this. So many wires. It looks like a monster. I have connected the power cable in there. Before applying current to the charging boards, I need to check if the voltage is within the right range. If it is outside the range, there is a possibility that the charging boards could break. 5 volts is preferable. 5.09 volts. Good. I will check the other power supply as well. This one is 4.88 volts. It's a bit low. I'll adjust the voltage. I'll set it to about 5.1 volts. Now that it's ready, I'm going to turn on the power.
お願いだ、壊れないでくれ。
It's working. No smoke is coming out. The LED lights on the backside are on. There are LED lights that indicate the power is coming in. They are all lighting up without any issues. Amazing. I forgot to add one more thing. I will use this acrylic sheet as the top board. Looking at it again, this is crazy. Only half of the ports are used yet. Only 50 cables. But even at this point, it already looks crazy. I quite like the power supply wiring at the back. I'll try it out. I connected USB cables. When I connect this smartphone, it should start charging. If I had 100 friends, I could have tried charging 100 devices at the same time, but
I have no friends.
I don't have 100 smartphones, and inviting 100 friends at the same time would be extremely difficult. Therefore, I haven't had a chance to test the capability of this USB charging station that can charge 100 devices at the same time. By the way, you can charge Apple products as well. Use a USB-C to Lightning cable and connect it to the phone. Then charging starts. You can charge not only an iPhone, but also an iPad. Charging has started. The first work of Extreme Electronics series, the USB charging station that can charge 100 devices simultaneously, was successful. I'm not sure if I'll make a second video of this series. If this video was helpful, please comment, like, and subscribe to the channel. Thank you for watching.